I had a couple of questions about the surds test that I set. So people struggled a bit with question 17 and question 18. So I'm just going to go through those now. So question 17 was changing this fraction into this fraction. So there's some clues that we can identify from the answer that we are aiming for. There is a root 2 at the top here, and there is a 1 here. So how would we get from that 1 to that root 2? Multiply by root 2. And then because it's a fraction, we have to do the same to the denominator. However, even if we didn't have this answer to work with, the first thing I would do is multiply the denominator by root 2, because it will get rid of this root 2 in this fraction here. And then again, because we have to do the same to the denominator as the numerator, when we multiply by fractions, we would have to multiply by root 2 over root 2. So this is what I'm going to do first. For the numerator, that's really easy. I've got root 2 times 1, so that turns into root 2. For the denominator, I've got 1 over root 2 times root 2. I'm going to actually write that out as a bracket first of all. Okay, so if I multiply root 2 over root 2 by our original fraction, I get 1 times root 2, which is just root 2. And then I get root 2 times this entire denominator. So this is the fraction that I had got to. The numerator stays the same, but I now want to multiply out this denominator. So root 2 times 1 over root 2 gives me root 2 over root 2, which is just 1. And then root 2 times root 2 is 2. So I've got root 2 over root 2 over root 2 is 1 plus 2, which gives me root 2 over 3, which was the answer that we were looking for. If you found this one tricky, it might be because you tried to apply the standard rationalising to this one. So perhaps you did 1 over root 2 minus root 2 times 1 over root 2 minus root 2. This would work, but it's a bit horrible to work with. So the numerator would turn into 1 over root 2 minus root 2, and the denominator would turn into 1 over root 2 plus root 2 times 1 over root 2 minus root 2. So this was what we had got to. The numerator I'm going to leave alone for the moment, so I'm going to say that's 1 over root 2 minus root 2. Then I'll have 1 over root 2 times 1 over root 2, so that gives me a half, plus root 2 over root 2 minus root 2 over root 2, so I'm not going to write that down because that will cancel. And then I will have minus root 2 times root 2, which is 2. Okay, from there, if I multiply by 2 over 2, then at the bottom I will get 2 over 2, which is 1, minus 2 times 2, which is 4. And on the top I will get 2 over root 2, which is root 2, minus 2 root 2. So I end up with minus root 2 over negative 3. The negative signs cancel, so I get root 2 over 3. So I do end up with the same answer, but it's not very nice. It's a really long method. Look at how much working we've had to do to get there. It is much simpler at the beginning here to just multiply by root 2 over root 2. and then work from there. Question 18, I would use a similar method. So we've got 2 over 1 over root 3 plus 1. And the first thing that I would think is I want to get rid of that 1 over root 3 in the denominator. So I'm going to multiply by root 3 over root 3 first of all. So I get 2 root 3 over 1 over root 3 times root 3 is 1 plus root 3. Now this is similar to what you've had to do before. So I'm now working with 2 root 3 over 1 plus root 3. I'm going to multiply that by 1 minus root 3. So I would end up with 2 root 3 minus 6 over 1 plus root 3 minus root 3 minus 3. So I had 2 root 3 minus 6 over 1 minus 3. That is 2 root 3 minus 6 over minus 2. Because I'm dividing by a negative, I'm going to divide each of these by -2. So 2 root 3 over -2 gives me minus root 3. -6 over -2 gives me +3. So I can rearrange this to do 3 minus root 3, which was the answer that we wanted. We could, at the very beginning here, have multiplied by 1 over root 3 minus 1. And it would still give you the same answer, but just like with the previous example, it would be a bit messier to do. I'm not going to work through that one because multiplying by root 3 over root 3 is the easiest method of doing it.